computer vision people do only image video processing, and speech people do only like some one-dimensional signal, speech, music, audio, that kind of things that they work on. So today the interesting thing that we see is all these people do only one thing. What do they do? Code in PyTorch. Okay, this is unfortunate thing. So speech people did not know anything about speech, image processing people did not know anything about image formation, image creation, what is image. Language people did not know anything about language. What you need to know is only deep learning. It's a sad situation to be in, and we should be coming out of this as we move forward. Yes, sure. How do you do that? Okay, so that is where we are now. So I just want to start with what did happen. So this entire AI of today is data driven. Isn't it? So you just get tons and tons of examples and give it to a deep learning algorithm or a model or whatever it is, so whether it is a MLP to CNN to transformers to RNN, I don't know what all acronyms that you are aware of it, all of them, you give it solves the problem. This is what we have been taught and we have been practicing. And now let us understand what happens. So assume I give a picture like this and give it to a deep learning architecture, and we can force it to say something like, so it's a male, or it is walking, or it is jumping. So what is this problem called? Classification. So you can formulate a large number of classification problems. All of them follow exactly the same pattern. What do? We collect examples, the data or the image, plus some label. The label could be verb, label could be noun, we don't care, but the method is same. This is not the only thing that we do, isn't it? What else we do? We also do like this. So we say, give us a picture and start guessing the age of this person. Or tell me which position this person is. So predict a real number. And what is this class of problems usually called as? Regression. And now if you look at in machine learning, whatever technique you learn, people say you can use it for both. Then why do you call them as different? People teach you neural network and then tell you that okay, you can use it for both. People teach you support vector vision, then people tell you that you can use it for both. But we call them as different. Okay, not only that, we do more tasks, like this. Okay, what's the difference here? What are we predicting? What are we predicting here? Posture, okay, that's with respect to this picture, that is right, but what do you call for that structure? Is it a number? No, is it a vector? It's a graph? It's a graph or a tree, or so you can now predict you have capability to predict numbers or labels. You can predict real quantities, vectors, real vectors. You can predict strings. You can predict graphs. You can predict trees. Method is simple. Method is same. What is it? Take tons and tons of examples, give it a neural network and define an appropriate loss function and train a neural network. And what algorithm we use for neural network? Backpropagation. Whatever you complex neural network theory you say, at the end of the day there is a backpropagation algorithm that works. Then we don't even implement backpropagation. We just use from PyTorch. What is a favorite programming language here of PyTorch? What is it? PyTorch. Okay, these are all PyTorch people. Okay, fine. Good. No, it's okay. No difference. Multilingual doesn't count PyTorch and TensorFlow. I should have put that also somewhere. Okay. Now, along with this, okay, so what happens in this sort of a setting? So the solution is we have good appropriate examples we collect, give it to machine learning algorithm, and it produces what? It produces a solution. You call something as a model or a deep learning algorithm or a deep learning solution that can be used at the test time. Now what the standard technique is, learn from large realistic example, evaluate on realistic data. This is very, very important. You don't know how good is it. Okay, so entire world has started to talk about only real data today. This change happened not just now, so you people don't know the history. The deep learning era people never read the history, that's what I was told. So the history tells that in the past there used to be a word called wild. You can look at history of word wild in AI literature. 15-year-old, not very old. So the wild came because earlier people were working on examples or data collected, curated very carefully. So when we did face recognition, we asked everybody, all the graduate students or the students in the institution to come and take a passport size picture or the type of picture that you apply for visa and build a face recognition algorithm. And when this big terrorist attack happened in the history, people tested it and it thoroughly failed. Why? Because the algorithms were trained on one distribution, which was nice passport size visa photographs, and we were assuming that the terrorists are going to stand in the airport like that in front of the camera. That never happened. And then people immediately, oh, let us not do that. Let us start something called a wild. And one of the first data set in that space was labeled faces in the wild, LFW. So what they did, they collected lots of images from internet. Whose images will be there? Celebrities. Okay, celebrities keep their images, and then all their images were collected, LFW dataset was built, and face recognition algorithms were built. Then what happened? Then some of the deep learning algorithms started to think that all the human beings do a lot of makeup. Okay. So this is the type of biases that, we'll talk about that as we move forward. So this is the story, and how, so this is the problem. So statics on the real data tells how good or how bad is the solution. So this could be bad if your data, the training data is bad, your solution is bad. It is not going to generalize. And what is our goal? Our goal is to generalize to unseen situations, examples. And if you want to do that, you need to know what type of training data you are working on. Okay, I still know a lot of people. This way, you may think that many of you are nodding your and think that you don't make that mistake. I can tell you, a lot of industries, careful people ahead. Even now I see interacting. Look, Professor, we are carefully curating the training data. They are doing with good intention. Remember, they are doing it with good intention, but you don't know what is going to happen later. Okay, so and how do you learn? You could define a loss function and train using backpropagation. We talked about that. Now, when this entire story started to succeed, so this way the story possibly started in 2012, not even 10-year-old possibly the story. That's what there's of history. 10-year-old when this entire thing happened, people were excited that this is working. Then came another set of people who started to say that, given such small representations, I can write essays. There is a great person, like Andre Karpathy, who was possibly more famous than his advisor, who was super famous. Like that kind of a person was super famous at that stage. Why? Because he wrote a very nice blog called Unreasonable Effectiveness of Recurrent Neural Network. And what did he do? He collected a lot of Shakespeare articles and showed that RNNs can write like Shakespeare. And what he had access to was some LaTeX file about some algebraic geometry, and he gave it to it and now asked the recurrent neural network to write algebraic geometry. For people like us who are not experienced or who are not experts in all these sort of things, this looks to be a valid theorem and proof. We all nod our head. Good theorem. And pass. Then came somebody else, 2015. Yeah, good fellow. Who, over a cup of like a coffee or a drink or whatever it is, tried to prove that, look, you can have a very different way of like a training neural network, and now can generate nice new things which from nowhere. And of course, this is possible in this case too. Speech. Okay, maybe I should have put ChatGPT today. The slide might have updated the ChatGPT. Okay, but I'll try it next time. Okay. We all reuse slides. Okay. You don't do it every time. If you assume that I am just preparing only for this, you're wrong. Okay, so now what happens now, given that these two we know, what is the next step? The next step is to do this. Anything to anything is possible today. Anything to anything you can translate. Am I right?
Yes.
Yes. So people used to say that if you use Microsoft Word, anything that cannot be justified can be justified. So now similarly, now anything can be translated from anything to anything. Wow. Multimodal and everything. Am I right? Agree? Then why are you here? There is no future for you left. It's all done. Isn't it? You are wasting your time then, if all of them are done. Okay, quiz. I want to do something like this. Starting from a black and white picture, I want to create a color picture. Is it possible? Why does it work? How do we get training data for such a task? Yes. Yes, yes. You raise your hand so you can answer. No? You raise your hand to attract your friend. Okay. Okay, so how do you get training data for such a task, and is it going to work? Anything to anything is possible. That's what a little before you agreed.
Not always.
Not always. Why not always?
Say you give a picture with red color and make it black and white. And take a picture with yellow color, full yellow, and make it black and white. They will be same. So theoretically it will be possible. What color?
Theoretically, this is not possible to do. Then why did you say in the previous slide everything is possible? Now this is not possible. You are saying this is not possible. No? Are you saying this is not possible?
Not in every case.
By the way, this is a picture from at least this picture and this picture are from a CVPR paper which got published maybe, I don't know, 5 years back. So don't say it is not possible. It is possible. Okay. Now the question is, why does it work? And how do we get training data for such a task? How do we get training data for such a task? Artists are at demand now. You take black and white picture, paint, get a color picture. No? It should be the opposite. Beautiful. Okay. You need to be. Oh, if I don't use it, it's okay. I'm speaking reasonably loud, I usually say. Yeah. So if what do we do? Today, one of the smartness is in creating or how to exploit or how to get the training data. Not everything is fully supervised. ChatGPT is not trained with all your questions that you are going to ask. Okay, so you need to have smart ways of training, and one way in this example could be this picture you take. You just take tons and tons of pictures from internet and use a standard Photoshop technique to create black and white one and play. And why does it work? Okay, now the next question is, why does it work? Why it should work, why it should not work. So you need to have a feel. When you solve a problem, don't assume let CNN solve the problem or let Transformer solve the problem. You need to have a feel about whether the problem is solvable or not. So I always tell my students, before you code, you tell me what is accuracy that you are going to get. You need to have an idea about what is going to be the performance. So similarly, are you going to get some reasonable performance or not? How do we know or why this is working? These NLP people were worried about this fundamental, very important problem. Professor Pushpal Bhattacharya possibly spent a good amount of time discussing this issue about machine translation. And what do machine translation people do? They take a sentence from English, another sentence, the corresponding translation Hindi. So you have X and Y, you have labels, or whatever it is. The one end is a string, the other end is a string. You train a deep neural network or a machine learning algorithm to translate from English to Hindi. And this was going on for a while. And at some stage, people started to realize that this is not going to scale. If you want to scale to hundreds of languages or even 20, 30 languages, and if you want to get tons and tons of such training data for all pairs, if you have 20 languages to worry about in India, like a country like India, to minimally to start with 20 languages on this side, 20 languages on the other side, what, how many pairs? 400. And how many examples? Millions of examples. Even if you pay 5 rupees per one example, nobody can afford, even Google cannot afford to build such training data. So this seems to me like, I think every time people who are not familiar with this say that, no, we can just create training data because it's easy to create. I can translate from English to Hindi, yes, you can translate, but tell me the number of sentences that I want. This is not scale. So very nice technique came around that called multilingual machine translation. What is multilingual? People argue that, look, you can put all languages on this side and all languages on this side, and you don't have to have all pairs of translation. So you don't need a Telugu to Hindi example. So this was a beautiful, like a breakthrough in making sure that you can just start with very small, so with practically no training data from some language pair to some language, you can start getting working systems. People talk about today, what do you call that? Zero-shot learning style of words. You heard such words? Few shot, zero shot, etc. So the training data is very small and we can still build systems of that sort. And today all the Facebooks and the Microsofts and the Googles and all the translation system that you use is using similar techniques. Architecture may change, whether it is what type of encoder, decoder we use could change. This is not enough. So people worrying about like, look, once this translation is working, the translation is working from text to text. This is not happening. So I'm talking to you, and if you assume that this is going to work, the real translation will have to be speech to speech. Okay, if you want the translation to be from speech to speech, so which means one easy way of thinking. So how people think of this problem? So one way is like engineers think about a solution where we are familiar with blocks like ASR. What is ASR? Speech recognition. Then do a machine translation, then do a text to speech, and you can translate from English to say Spanish. But what is more interesting is, why are we going through this route? Why not this route itself? Which one will work? Which one will give better performance? First route or second route? Bottom route or top route? Top or bottom? Which one will give better performance? Eh? Top. Why? Why? Pardon? Okay. Okay. Okay, so his argument is that if you take the bottom one, there are every block can have error, and these errors compound and errors will be higher, while the top one will have less errors. Do you agree? Nobody betting for the second one better? No? Why? Pardon? If you are asked to solve the problem, will you take the first route or second route? Pardon? Depending on the task is same. Task is English to Spanish. Will you take the first route or second route? Yes. So if you are asked to write a program, will you write a single big function or will you write multiple functions? Why? Why? It is slow. There are a lot of function calls. No? Errors can compound. No? Why? Okay, so there are a lot of advantages of going through this route too. Of course, today practical routes or today the performance, whatever demonstration that you see, possibly you take the bottom route. Because each of these individual models can be built with appropriate data easily, while the top possibly has a far more complex model to learn. And when the model complexity or the task complexity increases, what about the training data requirement? That also increases. Okay, so your requirement for the data, because the task is big, the training data will also be big, but still people. So, but the people have agreed that this is the way to go. That you are no longer just looking for only text-to-text translation. You really need to look at speech-to-speech. So we saw that okay, this is the right time for computer vision people to get involved. We thought that okay, the real problem will have to be face-to-face.
TensorFlow 2.0 incluye muchos cambios en la API como Esta versión de TensorFlow 2.0 incluye muchos cambios en la API como reordenación de argumentos, renombrado de símbolos
Okay,
de
so
la
what
API.
did they do? So
La
this
herramienta
was
de
a paper we wrote in
actualización de
2020.
F2 ayuda a la transición convirtiendo script Python de
We argue that now the translation will have to be face-to-face.
de TensorFlow previo.
We never realized when we were writing a paper in 2020 that we are going to get into a situation where the face-to-face video calls are going to be the norm for the next couple of years. Okay, so this system now, the solution now is, of course, this if you want to go through the direct route, the challenge is very high. We go through this indirect route. We break the problem into smaller problems and then solve it, and then this sort of like a face-to-face translation is possible. So one of the use cases of this is content creation. Now this is very important. If you look at a country like India, which has 18% of the world population, but only 0.1% of the internet content is Indian language. Practically there is no Wikipedia content. If you are talking about Wikipedia in Indian languages, or I am sure the Nepali or any other language dialect that you are comfortable with or you're fond of, the internet content is practically zero. The best case of Hindi itself is quite bad. I don't have a graph here to talk about that. So which means that even the techniques that use harvesting the text on internet and building language models is not going to work. So that need technologies that can establish better equality and opportunities across geographies and people. And if you want technology that to scale about, say for example, like look at the content that you have in English content that you have in for educational content worldwide, the Coursera's of the world. Where is it it available. So that you can complain about the network issue, the resources issue, but that is not enough. At the end of the day, the student who is learning this will have to understand. Something as simple as in some of the studies that we have carried out, people have found that it is not even sometimes the language, it is also at the level of even pronunciation. So there is a need now of translating the English videos of faculty members taught from Stanford to Bangla accented English. Isn't it? Otherwise I can't understand. I don't understand most of the time. My son understands better because he watches all these like YouTube videos. He understands English better than me. So it is difficult to, it is not the language sometimes. It is the accent. So you need the content to be created, and if you want to impact the society, or if you want to create jobs in the rural areas, there are lots of how-to videos today. How to do things. And this is very important. And the penetration of the internet, even the network, the cost of internet, the availability of internet in the rural areas, lot of breakthroughs we have seen. But where is the content? And who is going to create this? And you need this sort of thing. Okay. And this is a very, very important for countries like this. Not only that, so there are 4 arguments. So if you want to look at even a perception task, if you want to look at a very idealistic way of looking how the perception problems need to define and solve, you realize that the advantage of bilingualism is shown in many, many situations. The people who can speak multiple languages have better brains. Don't worry, be happy, you all can speak multiple languages, be happy. There are a lot of parts of the world people can speak only one language. Yeah. Isn't it? So there are there's proven records from cognitive science. Human being, let's say, the people are trying to different modalities of it. There are a lot of interesting studies from cognitive science, neuroscience on multilinguality, multimodalities. I just want to show you a small video about that. So this, if you haven't seen it, you should see how what you hear depends on what you see. I'll show you video. I'll play this.
Cambios en la API como reordenación de argumentos, renombrado de símbolos.
Can you hear? Can you hear?
But look what happens when we change the picture.
close your eyes, then you hear something else.
And yet, the sound hasn't changed.
So what it shows is it's the same sound. When you look at the screen, what you hear is different from when you hear without looking at the screen. What does it tell? What you see is influencing what your audio perception. You can go and read about this effect. This is a very well-known, I think there should be some Wikipedia page or appropriate articles if you want to know more. Okay, so I want to still move forward. So we have still not reached anywhere. Some time. So what do we perceive? So this was always the worry or concern. So this was an experiment which was done in 2007. I think part of it is PhD or something like that. So the story, so what they did was something very interesting experiment. You flash a picture. Okay, just flash a picture and ask people to write what they see in it. Okay, you flash the picture for 40 milliseconds, then somebody writes like this. You flash the picture for 500 milliseconds, then people write like this. So it is clear that if you are shown the picture for a longer period, you will write about more, and your understanding is better. But the one small thing for us to start observing from here is the task of, say for example, image to text is a proxy task for knowing how much we understand the picture. So origin of our image caption. So this captioning story also evolved over time. We started with the nouns like cat or dog or something, walking, jumping style of things. We talked about nouns and verbs. We talked about then phrases, then sentences, then paragraphs. People started to talk about how this translation happens. And systematically, I think our understanding of what is there in the picture, we were able to calibrate by the richness of the text that we were able to capture. And lot of studies in NLP or the text processing has helped us in defining how to define or how to measure the progress of the larger community. Now today, the vision and language has evolved into a full-fledged research area. You submit a paper anywhere, you can tick this as an area of expertise itself. Is there a way to remove that from mark? So the solution now in this entire space is systematically something like this. There's a visual input, there's a textual input, and there are encoders, appropriate encoders. All your favorite neural networks can be put into those boxes. And then like the essence or the meaning of it come out of it, the type of picture that we showed. We were seeing only one of this box and one of this box earlier. Now we are able to see two different boxes which come because why? Why this box and this box are different?
Different modalities.
Pardon?
Different input modalities.
Yes, the type of modality that come are different, and accordingly these two boxes are somewhat different in architecture. And of course, so now which means that today if you are ever looking into, say, a modality, you immediately know that, oh, this is a modality, or this should be the box, this should be the backbone. So such nice understanding that we have built. And then you have a decoder, then you can, depending on the task, you define appropriate loss function, train. So this entire thing has systematically generalized into a number of problems that you can solve. So one of the prominent one that people started to talk about was this visual first answer. I think 2015, Devi Parik's work, which pioneered the space, where she started to introduce this sort of questions with a picture and see how do we come with answer. And this tells us also about how much we understand. Of course, there are also practical applications what can motivate. And now people talk about like why are you limiting only to text and vision? Why don't you also add audio? As I mentioned, so you should also, as a student, you should also guess what is going to happen next. Okay, you are all future researchers. So what does it mean? You need to know what is going to happen next and start preparing for it. If you see vision plus language, there are papers getting published. I told you, like if you have only one modality, you can add another modality and get your first paper. How will you get your second paper? Add the second modality also. Look, have practical strategy so that you move forward, isn't it? So that is how you plan. So sometimes you don't see such papers. Now what does it mean? When you don't see such papers, you should not think that you are thinking wrong. You should be happy that you are thinking ahead of others. Isn't it? Like when Google doesn't give you an answer, that is not a bad situation, that's a good situation to be in. Okay, be confident. You should be able to solve the problem and you will be the first to solve the problem. And it's not easy. As a student, sometimes there's a big jump from a world where you believe the teachers and textbooks give you all the knowledge. And today YouTube also into that list. Please give all the knowledge to you creating the knowledge. And there's a big jump in maturity, big jump in thinking, big jump in behavior that you need to change. And that is not easy. And that's that when you do the transition, be confident. You can do it and you should do it. And the papers that you're reading, they're all like people like you only. Okay, there's no big difference. Just do. Okay, so naturally when you are able to do two, then people ask the question, why don't you add audio also? And these people will have to wait up till 2022. Like you just lost 2 years by 2 years only you lost it, isn't it? So when you see a paper, so my students come and tell me sometimes, sir, I see this paper like somebody has done our idea. Look, be happy that you are thinking like them. Rather than complaining about them, you are thinking of the best ideas, you are thinking like them, you are in the elite group of thinkers. Similarly, when you miss a paper, don't cry about it. You narrowly missed, next time you will make it. Okay? Many practical use cases. So today, we not only these sort of abstract use cases of understanding the perception and measuring the level of perception, today people can now talk about, like you can start asking questions. For example, a blind person wants to know whether a switch is on or off. So some of them very, very difficult today. Like, can I ask this question with a phone pointing to a product? Is this food good for people who are diabetic? Or who are allergic to this? So your chatbot, your Alexas and Siris could do far more and personalize it to you if it can also read the product, understand the product, text sometimes, visual cues sometimes. So you have to bring all this together to have effective solutions in this space. Emerging space. So now this happened. So look at another one that you look at the papers 2008. And if you look at the conference name, all of them will be almost the same. Great people think alike. I think, no, there is a lot more things going on in the back possibly. People know each other, how goes on, etc. So what happened around that period was both people started to look at these cues in a different way. There are examples of it. For example, by looking at picture, do you know from where the sound gets created? I see somebody playing a musical instrument. Now from where the sound is coming? The localization of the sound. Or, so a number of different ways in which can be separated. So it's a big thing in the music. If you are a musician or if you work with music instruments, etc., you will realize if you ever want to separate the different tracks, the challenge also is the utility of it. It works today. And one of the very interesting things that came around that period was to check whether a speech is in sync or not. What is in sync? The audio and video are in sync or not. So give audio and video, and it says they are sync or not. And just like the same model, say architecture. See, architecture design, every time students ask the question, how do I design the architecture? Look, I told you, it's very easy. You have one big box here, another big box here, third box. Now what goes inside? I told you how to pick that also. So it's easy, it's not very complex. People confuse you by telling it's very, very original, etc. No, very easy. So now when you do this, how this happens? So the smartness is in not designing what goes outside of the box. Smartness is in how the problem is formulated. I asked the question of colorization. Now let me ask the second question. How to get training data for checking whether audio or video are in sync or not?
So you take a sync video and on sync.
Absolutely, beautiful, good. You lost the opportunity, it got done in 2008. Yeah. So this is very, very easy, say smart tricks, and which work extensively, which work very well, and it is useful in a lot of problems. We have extensively used this, modified this sort of architecture for some of our work too. So when you have such a audio and video here, now what happens? So you can have alignment, representations, alignment. You can also think of multimodal representation. So remember, there's another big story that people talk about. Deep learning is all about representation learning. So the big representation learning group, people who talk about representations can be learned very effectively. You can learn representation which has semantics, like all the word to X stories, king minus queen is equal to something, etc. All these nice stories people talk about. So you can now have multimodal representations where this, and this can be at the same place. Beautiful. Think of it, what you can do with this now. Different type of sentiments, different type of expression, different type of meanings. And you can translate from one modality to another modality, like a picture to videos, picture to animations, text to animations. We have not reached a stage where I can write a movie script and the movie comes out. That is a problem for you to solve. Okay, I should also leave you open problems to solve. So the trios that we are interested is this now. Okay, so now I just want to ask some questions. So it's just questions that I prepared for some of the students in India, but they are all valid here. So people complain, like when you complain about lost opportunity, I always ask people, like, look at this as a positive way. People complain, look, in India for Telugu, I don't have data, training data available, etc. Look at this as an opportunity. You can do it because if they have done in the past, you are jobless. So such as example areas, problem themes where being in India or being in Nepal could be advantage in doing research, in computer vision research. Okay, just find and replace Nepal, India with Nepal, it will work here. Okay. So tell me the answer to the third question. What is that being in Nepal, being in Kathmandu? What is the advantage of doing? If you see only disadvantage, you are sitting at the wrong place. You need to see advantage. There are always people who look at only half-empty glasses. Isn't it? You need to look at always the positive side of it. So tell me so being in Nepal, being in Kathmandu, what is your advantage of doing research? Pardon? You have seen the problem of? More closely. Yes. What else? Some more. Absolutely, diversity. Okay. Yeah, yes.
We are certain type of people where research is not done like our places. Research are not done, so we can build that research.
Absolutely, beautiful. Okay. What else?
Using historical heritages.
Yes. Unique historical. Beautiful. What else? all what you mentioned is all right, but they are all technical problems. Tell me there are practical tricks that you can always use. You have less competition. Isn't it? So I always say, look, you write your first CVPR paper, you will be the first person from Nepal to write a CVPR paper in the history. Oh, whatever, I'm just talking about. Look, it is not joke. Like you realize that. Look, in a country like this, possibly you have the potential and you can do that, and you should do that. But look at it. There is a historic advantage. So, and you are the first. Just like we all learned as a student, like there's the first person who went to Everest. Oh, great. like people will salute you later. Like you are the first one to do something very, very important. So do good research, and it is very easy. So it's not seen as a disadvantage always. So we all think that being in a not super developed competitive world is a disadvantage. No, it is an advantage. Okay. Why is it? It's an advantage for you because you can still perform very well today with all the internet resources, globalization of the knowledge, democratization of the development in AI. Like a lot of things are easier for you to do from here. Whether you do from here or from Boston, there is no difference. At the end of the day, it is you who is doing. But when you do for the first time, and that remains in the history forever. And there are a lot of first times that you can do. Isn't it? This is a territory, the green field is open for you, and you should exploit it. Okay, so let me move forward. I think I have not still reached 20 minutes. 20 minutes for the tea break. That's our understanding. Okay. So I'm okay with whatever you people think whether we can stop. I have a lot more videos to show. Okay, I want to show you now. So the talking phases, that's where we thought we want to talk about most of our research. I think I'm just warming up is done. So I want to get into the topics now. So the talking videos, there are a lot of interesting videos, data available publicly. And remember, again, I talked to you about the video for the training data, how do you harvest it, how do you create it. There are smart ways of creating from publicly available videos, and that is what people have done. It is not like these are all when you went ahead and captured the hundreds of videos. So now what you can do with this? So you can now understand what goes on, who is speaking and what do they speak. So what you do, your lip movements can be converted to text. That's what we thought. We started by saying anything to anything is possible today. That's what we decided, isn't it? Lip movement to text is possible today, and you can get all the dialogues of the past movies. There is no need of somebody to sit and type. Not just for past, even today's. And it is very important for people who cannot hear. We can develop technology, and this sort of technology can run on your mobile phones today. Good things to try. And of course, the backend is of some of these are all your favorite transformers. Now, when we saw this we were doing some of this work, and suddenly we found that the machines can be trained to read lip accurately. We found a very serious issue that we are not able to train humans to do lip reading. I'm not joking. Who will teach? The special schools are disappearing. There is no attraction in teaching such places. The Braille content, if you look at Braille books, were very common at one stage. Now today nobody is ready to publish Braille books. No money. So is it possible to teach people So we were wondering, is it possible to teach? Can we create MOOCs for lip reading? And at the end of the day, how do you teach? You show people, you learn by practice. You learn, there is a pedagogy also has some level of like a curriculum training, like in terms of easy examples, difficult examples, how do you know feedbacks, active learning. There are a lot of interesting machine learning terminology. Real learning to machine learning, it has gone back. Now we can actually use many of them, could be possibly for designing the content for teaching people. Not only this, we don't have this. We all use this, and we forget about the community who cannot be plugged onto this. You need to develop that plug. Technology is right. Papers are out, code is out, the rest is with you. Here's an example.
We talk about the relationship between the wavelength, the frequency, and the speed of electromagnetic radiation. The type of product of the wavelength and the frequency is speed.
So this entire thing is developed, or speech is generated, the lip movement to speech. So you can just speak. And of course, this was one of the first papers demonstrated this so accurately in 2020. And of course, you always know when you show your first paper and impress you with the result, you don't realize that this was possibly trained on this person. So now it cannot be really used at the use case that you are thinking. So we need to continue. So this used possibly like a large amount of data from one specific individual, but it is still useful. I'll show you why some of these things are very useful today. So now we have better techniques which talk about like, can you do this person independent? You can generate speech from the lip movements even if you don't know who is this person. Let me check. It's the same model that works across people.
You don't deserve my grace. You don't deserve my grace.
So it is person independent and possibly like a far more accurate. I think we have an ongoing work. I don't have a video of that, which is possibly giving a far better quality of speech.
Using past experience based on similar situations to try to make meaning.
He's using past experience based on similar situation to try and make meaning.
What is the worst use case of this? Pardon?
Using incorrect translates, making you speak something that you haven't spoken.
No, that I have done enough. I did not show you that. Yeah, but the worst use case, I can look through the window and I can spy what people are speaking in the room. Pardon? Could be. You're right. I don't know whether they are aware of the technology, I don't know. But they are ready for the future technology. Yeah, so now I did not show you enough examples of this, the speech to lip. Speech to lip is so we have, when we wrote these papers, initially wave to lip and lip to wave. There are two, and everybody gets confused with both. So we can do both ways seamlessly today. And the use cases are very clear. So you can do both, say, a large number of use cases that we see of creating videos, content in many practical applications. You can look at wave to lip and lip to wave. So I think both the codes are also publicly available. You can play with it. some stage internet was all the wave to lip connect. Okay, so now of course deepfake detection is an interesting challenge. I will possibly comment about that a bit later. Maybe the second talk I can possibly talk about this a little bit more. So not only that, so you can do a lot of use cases. So if you look at this sort of use cases, people with a disability, if they want to speak, can you have simple systems, at least like they can communicate, like I want something, like if they need something, and is it possible for them to communicate with their friends or relatives or caretakers in various forms, and because they also have difficulty because their lip movements are also sometimes not natural. The muscles are have problems, and the movements are unnatural, and there are a lot of interesting learning problems that can exist and personalization issues that can happen with them. So there are a lot of interesting research happened in AVSR, audio visual speech recognition. So you can do the speech recognition, can they get benefit in the reverse? We talked about both ways it can help, like a speech can help vision, vision can help speech. Now how this sort of help audio, video, audio visual error rates. So here's an example of
and literally, break art as
So if you look at the top video, so you have like a denoising of the speech. So you can localize we talked about who speaks, we can find out, we can separate the speech. Now we can also separate the speech from the non-speech component. So look at this, the traditional, if you one way for you to appreciate those who know the signal processing, in signal processing we talk a lot about this filters. And many of them are linear filters or filters of different type of things that you can design with signal processing techniques, and the speech people are still big on that. Now, but if you really want to design the filters which are data driven, you want to remove everything other than speech, not filter. One way to look at it is anything that cannot be spoken by a human lips is a non-human speech. And if with such a data-driven filters or neural networks, you can actually remove a lot of sound that signal processing-based techniques still struggle with. Okay, so now the question is how this, one question that people ask always about is about how does this sort of multilingual methods that we saw many of the examples and in English, now if you want to translate or use this in, say, Nepalese, how do we do that? Isn't it? That's what we want to do? Yes, how do we do that? Okay. I'll ask my PhD student who worked on this to answer this question.
In general, most audiovisual models are trained on large-scale data sets which are collected from varying types of videos. These videos include videos from news clips, video calls, lectures, movies, etc. These videos also include several languages, allowing the network to generalize well to unseen settings. Finally, most audiovisual models focus more on short-term content
students are in disadvantage. Education was broken. Complaint was on internet providers. Of course, education was broken on online mode always. So now what can we do?
Operation that you have to do is the sampling operation.
Learn some signal processing
So
from my
for
teacher.
sampling, what you do is, instead of considering the signal values at every possible value of t, what we do is, we consider the signal values at certain discrete values of t. So here, in this figure, it is shown that we assume the value of the signal xt at t equal to 0. We also consider the value of the signal xt at t equal to 2 delta ts.
Okay, the rest you go and read the DSP book.
Xt at t equal to delta 2 ts, at t equal to delta 3 ts.
Okay, here is another example.
Shafi Bhaiya, I think he was doing rehab and he was coding at a very 120 wala pace, for us, something now pace. But I thought, okay, he's gonna go 120 and he promised me, वो मुझे ना body पे बोलने की like.
Okay. You can still do better. You know that? You want to clap and stop me? Okay, now you can actually do the comparing the video calls. So the entire video call, if you look at it, you remember the compression standards. There's two strong players in this space. One is called the standard people, who always play the standards. There is a compression standard. There's some edge, something. You know, all of them who might have studied signal processing, compression will know. There are standards of various type of video compression. Why standards versus non-standard? There's a non-standard people. Who are the non-standard people? All the video streaming companies which ask you to download a client. Why? Because their client can have their own decoder. Your encoding and decoders are proprietary, and encoding decoders are today learned encoders and decoders, not signal processing based encoders and decoders. Okay, that is why you see sometimes Zoom is better than WebEx or whatever, some such comparisons you make. Why? Because the compression algorithms of these methods are very nice. They compress talking faces. Why? Because most of the time these video calls, primary object of interest is only the talking face. So you can actually do better if you are interested in only talking faces in compression. I think we have some more results from one of our other work that we have been doing in this space. Is better than that. So if you look at this input and can you generate this?
Yes.
You make.
Can you finish doing the camera, all the things that
So you can do a decompression, or you can look at this from a super resolution or a high resolution viewpoint. You can also look at from a decompression viewpoint. Okay, reasonably your time. So to summarize, so what we did today was centered around the interplay of lip movement, speech and text. There are many aspects, the complementary properties of these modalities that help us in improving the cognition. The transfer between one modality to another, so anything to anything, but at least in realistic, very practical situations, we saw it is possible. What is possible? Generation of that, audio-visual content generation with a lot of practical use cases. And content-aware, data-driven compression and communication. So you can also do this content-aware, because this sort of method that we do with super resolution or compression, both cannot be possibly applied to arbitrary domains. It is content-aware, it's centered around talking faces, and accessible to people with hearing or speaking disabilities. There are a lot of improved applications for this. There are a lot of emerging foundational models. I think many of them are now the newer ChatGPTs and many other things come into this picture, where you see the very interesting The people have shown that multimodal backbones perform better than the single model backbones. Worries of generation. Okay, so people worry about generation. See, look at earlier we had always hardware-based generation. So we were using always camera or microphone for generating the content, like a speech content or visual content. And you had no complaints at that stage. Then we started to use software for creating content. And software people always ask the most photorealistic video, then only SIGGRAPH will accept. You have no complaints. The moment GAN generate face, you are worried about it. Why? So this one, you know, it is never realistic. You go and sit in the VFX movie and say, oh, I want to be as natural as possible, isn't it? You want a nice movie, avatars and actions and thrills, all. You plan them. Now you come back and complain about deepfakes. You should answer me after the break. Why is it so? You cannot have two standards.
Maybe the arrow is pointing towards me. So my face has.
You were earlier not worried about your hero and heroine getting generated. You are not worried. Now you are worried about you getting generated. Think you are becoming the superstar. Look positive. Okay, we need natural generation for human consumption. We need natural generation capability for machine learning and understanding of the process. We genuinely worry about this. It's a puzzle that we need to solve. Lot of interesting research directions. So I always believe these are areas where plenty of open problems tell us that, okay, look, we are guaranteed our living until we retire. So I have enough problems to solve until I retire. And all these problems are never going to get solved, isn't it? Underrepresented languages and geographies. Applications in education. Remember, the application in education today is only a broadcast. There is no feedback. How many of you know feedback? Control system. Some of you might have studied the need of feedback. Why do you need feedback? It's very important for stability, isn't it? If you don't have, you need to teach people, you need to have feedbacks. Teachers take feedback from the students, from their face, from their interaction, from their nodings, from their reaction. You need to have ways of knowing what to do, what not to do. This is possible today because you can even personalize the content creation for people. It is not like one lecture fits everybody's need. One speed will not fit everybody's need. Every student is unique in its own way. You need different ways of teaching. Assistive technologies. Embodied intelligence. All these are, you can see plenty of open problems and the guaranteed of your job. Okay, to summarize, interoperability across modalities, a new era of natural human-computer interface is possible today. How do we balance between the naturalness and ethical concerns? How does capability to synthesize correlate to analyzing the synthesis and analysis, or how these two are connected? So when you are able to recognize better, you are able to recognize, you are able to synthesize better. If you don't want capability to synthesize, you should also stop the capability to recognize. Are they connected? How are they connected? And will these areas come closer and closer? Or will they become farther and farther? Because there is a debate at some stage, will neuroscience and cognitive science and the deep learning come closer and closer? It came closer and closer, but I think it started to become farther and farther at some stage in the last few years too. Similarly, these areas, are they going to come closer and closer forever? Or is it going to diverge at some stage? stage. Of course, every area has their own uniqueness, their own strength. So these are interesting things for us to watch. Thank you.